Hello guys, welcome to another video in the series of coding. Today we are going to see the problem which is called k most occurring elements. So given an array of n integers in which elements may be repeating several times. Also positive number k is given and the task is to find the sum of total frequencies of k most occurring elements. So let's try to understand this problem with the help of some example. Let's say there are numbers 1, 1, let's say then 2, let's say you have 1 again, let's say you have 2, let's say you have 3, and let's say you have 4, and let's say you have 2, 2. Okay, something like this. So this is the array given to you. Now what are the frequencies of the elements? We have to see the frequency, not the element itself, but the frequency, the number of times in which the element appears. For example, if you take the element 1, it appears 1, 2, 3, 3 times. If you take the element 2, it appears 1, 2, 3, 4 times. If you take the element 3, it appears 1 time, and if you take the element 4, it appears again 1 time. Now let's say the value of k is given. For example, if the value of k is given 2, then what you have to do? You have to return the sum of the top 2 frequencies. So the topmost frequency is this, okay, and then the next frequency is this. So you have to return the sum of frequencies of the top 2 elements, which will be 3 plus 4, which will be 7 in this case. What if k is given 3? Let's say k is given 3. In that case, you can take any of these two will definitely be in our answer because they are top 2 frequencies, and then you can take any of these. So you can take 1, for example. You can take any of the ones. So in this case, what will be your answer? You can take, suppose, these 3, and then 3 plus 4 is 7, 7 plus 1 8, 8 will be your answer in that case. Okay. So this is the question. How do we solve this question now? So since it is given k most frequent, right? So the approach that comes to our mind is heap, using a heap data structure, min heap data structure. Okay, let's go through the example with this. So what we will do is, first we will store the frequencies as we have done just now, right? So we will store the frequency. 1 is occurring 3 times, and then 2 is occurring 4 times, and then 3 is occurring 1 time, and then 4 is occurring 1 time. So I have stored the element corresponding with its frequency. So I will just iterate over the array once and get this. This is easy, right? So you can use a map data structure to store the element and the corresponding frequency. So let's say we have these pairs, element and the frequency pair. After this, what you have to do? If you sort, see, what is the brute force approach? Brute force approach is sort the entire thing, right? Sort the entire thing. If you sort the entire thing by frequency, of course you will be able to get the frequencies, right? So you will sort according to the second element, because second element is frequency. So if you sort everything, the time complexity will be n log n, and you will have to sort all the elements. But we don't need to sort all the elements, right? We just need to sort the k elements. We need to get only the top k frequencies, right? So rather than sorting everything, we will use a min heap data structure, because we have to find the frequency of only k elements, not we don't have to find for all the elements the top k frequency elements. So we will start with building the min heap. Okay, so first for example, we see here, right, 1 with a frequency of 3. So we have to put the frequency in the min heap. So I will create a min heap and I will put 3 in my min heap. I'll just put the frequency. I need only the frequency, right? So I'll put it. Okay, so I have created my min heap and I have put 1. Okay, so one element I have taken. So k is equal to 2, right? That means I can put at max 2 elements in my min heap. For example, when k is equal to 2, I can put 2 elements. There is only 1 element now, so I can still take the next element. Now 2 and 4, so I will take the next element also. So my min heap will become like this, 3, and then you have 4. Okay, you have these 2 elements in the min heap. Now next time when I am trying to take this element, right, 3 and 1, what I am seeing, when I am trying to take 3 and 1, already my min heap has 2 elements. If in case I have to take 1, if in case I have to take this frequency, when should I take this frequency? I need the frequency of topmost frequency elements, right? So what I will do, should 1 be a part of my min heap or not? I have to decide, because I already have 2 elements. If I need to include 1, I need to remove some element. Is 1 worth inserting in the min heap? Is it better to insert 1 and remove some element from this? No, because see, the min heap has elements which are greater than or equal to 3 in this case, because the topmost element is 3. This is a min heap. All elements in the min heap are greater than or equal to 3. Topmost element is the smallest. Now if I put 1, okay, if I put 1, let's say I remove some element. If I remove this element and let's say I put 1, Will I get the top two frequency elements? No, because in this case we are removing 3 and putting 1. We are putting a smaller value. This is not right, because we need the topmost frequency elements, right? So topmost frequency element are 3 and 4 only. So if there is a number, if 1 is smaller than the topmost element, right? So this will be we will be at a disadvantage. We need not put 1. Okay, so whenever we have a choice, now for example we have a choice whether we have to put 1 or not. In this case you don't want to put 1, because it will disturb the min heap and it will be disadvantageous to us. You want the topmost frequency elements, which are already 4 and 3. 1 is smaller, we don't need a smaller value. Okay, so we don't need to pop this. So this is element is also done with, we don't insert it. We go to the next element, again 1 is again smaller than 3, which is the topmost element. We don't want to put it, so we will not put it. Okay, we will not put it. So this will be our final answer. You can return 3 plus 4, which will be 7. Okay, let's say you have some other element. Let's say after this you had some other array which also had, let's say 5 occurring 5 times. Okay, so let's say in the original array there was also 5 that was occurring 5 times, 1 2 3 4 5. Okay, in this case what you would have done, in this case now we have 5 5 also. So now we will again compare with the top element of the min heap. Okay, already we have 2 elements in the min heap, we can only have at most 2 elements. So is it better to put 5 and remove 3? It's better, right? It's better to remove the smallest element and get a large value. We need the large values, right? We need highest frequency values. So in this case we will remove 3, we will rearrange the min heap. Okay, we will insert 5 and we will rearrange the min heap. So our min heap will become 4 and 5. So in this case the answer will be 4 plus 5, which will be 9. So this is the logic. Now let us look at the code. So the code is basically, first we create a map, and you need not order the map because we just simply need the frequencies. So I have just created a simple unordered map and I have just inserted the frequency. So I am going to each element in the array that is given to me and I am putting that in the map. So whenever I am putting it in a map, whenever I see it, I am increasing its frequency. So this map will have the element and its frequency. Now I have this. Now I can declare a min heap. So I declare a min heap. So the syntax for doing that in C++ is this. Normally it would have been simply priority queue int, but here we have to make it a min heap. So by default it's a max heap, but we have to convert it to a min heap. So you have to give this greater int, which will reverse the elements and it will make a min heap. Okay, so I made a min heap. Now I am iterating over my map because my map has the element and the frequency. So if the size of the map is less than k, I can put elements. I have no problem at all. If I have not got the k elements till now, I can easily put any element because I need top k elements. If my size is anyway less than k, there is no problem at all. I will just insert the element. Otherwise I have a problem, right? For example, size equals to k. In that case, you may have to remove some element. If you have a better element at hand, you will remove the smallest element from the min heap and then you will put your own element. So we have to check if it is worth removing. So if the topmost element is smaller, right, you have a better element with higher frequency, so you will remove the topmost element and then you will insert your own element. Finally you can just take the sum of all the values. You can empty the priority queue, keep popping the elements and take the sum of all values and return the sum. That is a simple logic. So let me just submit this and let's see if it is working. So let me zoom out a little bit. So now let me submit it. So it's working. That's it. Thank you for being patient and listening.